Everybody. Today we will discuss one of the most important equipment in our industry, which is the air-cooled heat exchanger. Through this lecture, we will uncover key principles, analyze practical challenges, and discuss a solution used in a real industrial environment. My aim here today is to deliver the subject in a clear, structured, and engaged way so that every idea become easy to understand and ready to apply. Okay, here the air cooler in oil and the gas industry. We will discuss overview of the air cooler heat exchanger and application in our refinery or gas plant and the petrochemical unit. The air cooler heat exchanger uses ambient air to cool the process fluid, also known as air cooled heat exchanger ACHE, air cooled heat exchanger. And this is the general shape of the air cooled heat exchanger. In many cases in the refinery of the gas plant, you cannot put air directly to cool down or condense stream because it may be boil up or something like that. So you have to use the air cooler first to adjust the temperature, then you will use the water cooler. So and there is many application for the air cooled heat exchanger. Okay, as we remark here, the composition of the air cooled heat exchanger is very simple. Here is the inlet header, and then the fend tube, then a bank, then return to the outlet here. Okay, the air cooler can be condenser air cooler, can be used for the compressor after cooler, which is very famous in the hydroprocessing unit, like the hydrocracking unit, like DHT unit and KHT unit. Product trim cooler to adjust the outlet temperature for kerosene, for diesel, whatever, and for the process of gas cooling and the LNG or something like that. Okay. The main type of the air cooler is forced draft and induced draft, natural draft, horizontal and vertical type. We will see all of them step by step, and we will know the advantage and disadvantage for each type. Okay. The first type is the forced draft, air cooler. Here, to specify the forced draft air cooler, you have to remark that the van located below the tube bundle. Okay, the air pushed upward in the direction from bottom to top. Okay, air pushed upward by the driving force of the motor, which moving the blades. Easy maintenance used in the process cooling. So this is a simple structure for the air cooler, which is the forced draft air cooler. And in this diagram, we can see clearly the main component of the forced draft air cooler. Here you find the van, okay, and plenum, which containing the amount of air going to the tube, and the tube bundle, which is here, okay, and nozzle for inlet and outlet. Normally this is the inlet and normally this is the outlet. Here the drive assembly and the column A, the column support. Okay, so this is the first type, which is forced draft. The other important type, which is induced draft air cooler. Here we can discuss the structure as the following. Van located above the bundle, a uniform air flow, higher thermal heat efficiency, and used in gas plant as a common design. Here in this structure, you will see through this diagram clearly that the van is above the tube bundle itself. Okay, this is the induced draft, and here is the plenum structure, and we will discuss this in detail later, which contain the amount of the air. The main structure for this induced draft is van, plenum, as we said, and the tube bundle, nozzle for inlet and outlet, drive assembly, and column support. Okay. When you select the induced draft and you stopped this motor, you have the capability to move the air naturally from bottom to top by the driving force of different density of air itself. So this type or structure highly recommended in the critical area, okay, for unit related to conversion or something like that. This induced draft is very, very recommended. Why? Because if you lose the power which moving this motor, you will divert or direct the air naturally from bottom to top and continue little bit amount of a of your cooling capability. Okay. There is a natural draft air cooler, no vane, use natural convection, large size and low efficiency, and in some cases horizontal air cooler, most common design, high heat transfer area used in refinery also. Okay, and there is in some cases a vertical air cooler, compact design, used when bloat space is limited or your unit space is very limited. The first question here is, what is the main component of this structure of the air cooler? I will give you around 12 points. We will discuss slowly to understand the main component of the air cooler. I will give you 12, not 9, okay? The tube bundle, which is, you can find easily the tube bundle here, okay? And this named as a fin tube. Why fin tube? Because these fins increase the area of contacting between the surface of the metal and the air, which increase the capability of cooling. Fin tube, okay? Here is the place of the fin tube. So transfer heat from the hot process fluid to the surrounding air. This is the function of the tube bundle. Okay, consists of finned tube to increase heat transfer area, process fluid flow inside the tube and the air outside of the tube bundle. Okay, as we can see here, this is the tube bundle. Okay, fins. What we mean by fins? I will show you the photo of fins. Yes, this is the photo of fins. Okay, fins function. What is a fins function? Here, extruded, G fin, L foot fin. This is many types of the fins which increase the surface area for contacting the air between the contacting and transfer the cooling medium and increase this surface area. Okay, these fins, many shape for these fins. What is the function? Increase the heat transfer efficiency by enlarging the surface area. There is extruded fins, embedded G type fins, and L foot fins. Okay. The vanes itself. The vanes function move air across the tube bundle to remove the heat. The vane itself here. If the vane is above the tube, you are working with induced draft, and if the vane itself is below the tube, you are working with forced draft. Okay, so the vane function move air across the tube bundle to remove heat. Axial vane, forced draft vane, or induced draft vane, as we mentioned. The vane motor here, as we can see. Okay, this is the element number 4. Vane motor provide mechanical power to rotate the vane, and this electrical motor usually explosion proof for sure and designed for continuous operation, can be fixed speed or variable speed. Variable speed to control the temperature more, okay, or can be fixed speed. The vane hub or blades itself, this is the element number 5. Function convert rotational energy into air flow. Okay, this blade angle affect the air flow and the power consumption. So these blades working with a special angle, and there is a variation in this angle to increase the amount of air flow or decrease the amount of air flow. Adjustable pitch control in many design. The gearbox. Okay, this gearbox to connect these parts between the motor and the blades. Okay, they reduce the motor speed to suitable vane speed. Motor run at high RPM. Large vane diameter is required. This is item number 6, which is gearbox. Okay, plenum chamber. This is the plenum chamber, which is like a cone here, and this is the plenum chamber, which is rectangular here. And the target of plenum chamber is to distribute air evenly across the tube bundle. Ensure uniform cooling and reduce the vibration and the noise. This is the function of plenum chamber. Okay, a header box. You have many type of header box. Header box working with plugs, header box completely covered, many type of header box to distribute the process fluid into and out of the tube itself. The header box can be clear in this shape. This is a plugged header box, and you have here inlet liquid or fluid, okay, go through this tube, okay, and return back through the other tube here, and this is the header box. You have two type of header box. Floating header, this is at the end of the tube to redirect the flow of the fluid, okay, and this fixed header, floating header and fixed header can be plugged type, can be bonnet type, can be removable cover if there is a one plate cover A here. This is the header box, which is very important. The header box controlling the movement of the fluid you need to cool. Like here the fluid, maybe some gas and the liquid here pass through the tube. This is the inlet, okay, and here you redirect back to the outlet. This is the header box, this is the header box. Header, when you see this figure, you know this inlet and outlet fixed header box and the floating in the other side. Okay, clear? Item number 9, which is supporting structure. For sure, you need supporting structure. Hold the entire air cooler assembly and include steel structure, walkways to check the air cooler yourself, and the maintenance platform. Okay, item number 10, which is louver. Louver function is to protect rotating equipment and to control the airflow direction and prevent the foreign object entry. This louver control the amount of air go through this plenum. Okay, if it is vertical, for example, it will pass 100% from the capability of the air cooler, and with angle you can control this louver. Vibration damper and bearing, the function is reduce the vibration and ensure smooth and safe operation. And for sure, number 12, the instrumentation auxiliary, like monitor the temperature itself, like controlling the vibration and monitor the vibration, and motor current indicator, and in some cases measuring the air A or expecting the air flow. Okay, what I want to tell you here, that after we discuss the main structure of the air cooler, I want you to understand how we can control the temperature. How we can control the temperature. Okay, here you have a TIC. This TIC at the outlet stream from the air cooler. It can go and control the pitch angle of the blade of the van of the air cooler. And normally you have 50% fixed and 50% which is variated pitch angle. Okay, this is the first type of controlling the temperature, which is van pitch control. Van pitch control. The other type of controlling the temperature here we can see in this diagram. This is the outlet temperature TIC, which controlling the speed of the motor itself. You can work or select during your design phase to work with a variable speed motor. You can increase the speed of the motor to increase the cooling efficiency of your air cooler. As you can see here, this is a temperature element, and TIC can act on the motor itself and increase or decrease the motor speed. In some cases, there is a bypass on this process. This bypass related to the TIC to open the bypass or close the bypass to adjust the amount of the fluid going through the tube for the air cooler. Okay. And there is also louver control. We know that the air pass from top to bottom like this, and there is a louver. If this louver is vertical, it will pass all the amount of air. Okay, if it works with angle, narrow angle, it will decrease the amount of air little bit and control the amount of air, making controlling of the temperature. Rarely you can find a steam header applied with the air cooler. This is for me a little bit new design or something like that. The steam header related also or connected to the TIC, and there is a louver also. So if you want to make a little bit heat, because in some cases for the overhead or for some towers, you don't want to go deeply with the cooling efficiency, okay, and you shut down the air cooler A and work only with B, for example, but in spite of that you are going deeply with the temperature. At this point you need to add some heating to adjust the temperature, so you can add in the design case steam from header to adjust the temperature related to the outlet temperature of the fluid working with this TIC. Okay, and finally I want to share the knowledge with the general design of the air cooler. Inlet number of tube and outlet number of tube can be equal or not equal or half in, and the outlet may be reduced. For example, you have eight pipelines at the inlet, and at the outlet can be four, or vice versa. You have four at the inlet and outlet will be 8. And the general recommended for the perfect design to adjust the velocity of the fluid inside this tube side to be balanced. For example, 8 at the inlet and 8 tubes at the outlet. Here at this small lecture and very short lecture, we discussed how to control the temperature using the air cooler, okay, and the general component of this important equipment in our refinery or oil and gas industry. Here the advantage of the air cooler: no cooling water required, low operating cost, and suitable for remote location. And the conclusion: it is widely used in oil and the gas industry and LNG for the gas processing. Selection depend on the duty and the climate and the space. Okay, I want to finally to thank you and to wish you happy new year, because we are at the end of the year 2025, and appreciate it for your listening. Thank you.